Have you ever just wanted a way to organize your thoughts with, perfect clarity? Well, that's the secret power of something called set theory. And don't worry, this isn't about scary, complicated math. It's really just a simple but powerful language for making sense of pretty much everything around us. So let's dive in.
Okay, so to get us started, here's a little puzzle for you. What could the days of the week and all the even numbers possibly have in common? I mean, one list is super short and specific, right? The other one goes on literally forever. So what's the hidden connection here?
And the answer is, they're both what we call sets. It sounds simple, but once you really get what that means, you'll have this amazing tool for organizing everything, from your shopping list to the complex data that, well, kind of runs our world.
So what is a set exactly?
Honestly, the best way to think about it is like a club. There are specific rules for who gets in, and there's a clear list of who the members are. It's really as simple as that.
All right, so here's the official definition. A set is just a collection of distinct objects. And that word distinct is important. It just means they're all unique. And those objects, or club members, are called elements. So you've got a collection and the things inside it. That's it.
Let's make this real. Imagine our club's rule is days of the week that start with the letter T. Well, if you go through the week, only 2 members actually qualify. Tuesday and Thursday. Boom, that's our set. And you know what? It works exactly the same way with numbers. So if the rule is even numbers greater than 3 and less than 12, we can just list out the members. We've got 4, 6, 8, and 10. They're the only ones that fit that description perfectly.
Okay, so now that we've got a handle on what a set is, we can start sorting them into different types, because not all sets are created equal. Some are small and manageable, some are mind-bogglingly huge, and some don't have any members at all.
And that brings us to a really key distinction. You've got finite sets and infinite sets. A finite set has a clear end. So the set of all people living in the US right now. I mean, that's a gigantic number, but you could, in theory, count them all. An infinite set, on the other hand, like the set of all even numbers, it just goes on forever. You could literally never finish counting its members.
Then we've got the real oddball of the group, the empty set. This is a set that has absolutely 0 elements. It's like a club with a rule so tough that nobody can join. We show it either with a pair of empty curly braces or with this pretty cool symbol right here.
All right, time for a quick pop quiz. These two descriptions sound almost the same, but one of them describes an empty set. Can you tell which one it is?
Yep, you got it. It's the set of women who are 120 feet tall. While there are definitely women who are 120 centimeters tall, that's about 4 feet, there are no known humans who are 120 feet tall. So that set is empty. It has 0 members.
Okay, we've got the basics down solid. Now we can start looking at how sets relate to each other. So what happens when one entire club is basically contained inside another bigger club?
Well, that's what we call a subset. We say set A is a subset of set B if every single member of A is also a member of B. You can think of it like a special interest group inside a larger organization. And we use this symbol, kind of like a sideways U, to show that relationship.
Let's see how this plays out. Let's take the simplest set we can, just the number 5. So what are its subsets? Well, obviously the set containing 5 is one of them. But here's the kind of weird but super important rule you just have to remember. The empty set is always considered a subset of every single set. No exceptions. All right, your turn to try. We've got a set here with 2 elements, 3 and 7. Based on what we just learned, can you figure out all the possible subsets it could have? So, did you find all 4 of them? You've got the empty set. Remember, that one's always there. Then you have the set with just 3, then the set with just 7, and finally, the set with both 3 and 7. See how we can build them up from all the pieces? All right, for our last section, let's pull all of this together. We've learned the big ideas, so now let's make sure we're totally fluent in the language of sets.
Think of this as your little translation guide, your Rosetta Stone for sets. We've already seen the subset symbol, the symbol for the empty set, and of course the curly braces. The new one here is this first one. It means is an element of. It's just a fancy, shorthand way we say that something is officially a member of a club.
Okay, let's put our new language skills into action. True or false, the set containing Sam and Bill is a subset of the set containing Joan, Bill, and Sam. What do you think?
That one is absolutely true. And here's how you check. You just go through the smaller set, element by element. Is Sam in the bigger set? Yep. Is Bill in the bigger set? Yep. Since every single member is accounted for, the statement is true. Easy as that.
Okay, how about a more conceptual one? This is where set theory gets really cool, because it moves beyond just lists of numbers and names. So is the set of all squares a subset of the set of all rectangles?
And the answer is true. Think about it. By definition, a square is just a special kind of rectangle where all four sides are equal. So that means every square is also a rectangle. And this kind of crystal clear logical thinking is exactly why sets are so important in fields like computer science and database design.
You know, that idea of finding rules and patterns, it brings us back to something we noticed a minute ago. Remember that set with two elements, 3, 7? We found out it had exactly 4 subsets. That feels like a pattern, doesn't it?
And that leads us to our final challenge. So, a set with one element had 2 subsets. A set with 2 elements had 4. So if you have a set with 4 elements, like this one right here, can you see where this is going? How many subsets do you think it has? The answer reveals one of the most beautiful and elegant rules in all of mathematics. Have a think on it.